This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're looking at example 3 for Unit 7. We're in Section 3. We're talking about sum and difference formulas and how to use them for various types of problems. So for this type of problem, we're looking at two different triangles, one that has an angle with alpha in it and one that has an angle with beta in it. And in these two triangles, we know the sine of alpha is 3/5. And we know that alpha is somewhere between 0 and pi over 2, so that means that it's going to be in the first quadrant. So let's go ahead and draw a right triangle in the first quadrant. And here's alpha. And since the sine of alpha is 3/5, I know that the opposite side is 3, and the hypotenuse is 5. And then you can either use the Pythagorean theorem, or if you remember your triples, this has to be a 3, 4, 5 right triangle triple. So for angle beta now, we know that it's between negative pi over 2 and 0. So negative pi over 2 is down at the bottom at the same place as 3 pi over 2. So we're going to draw our triangle in the fourth quadrant. And we know that the cosine is 2√5 over 5. So here's beta. The cosine is adjacent over hypotenuse, so that's 2√5. And that's 5. And if we use the Pythagorean theorem again to find what the other side is there, we're going to have 2√5 squared plus y squared is equal to 5 squared. So 2√5 squared is 2 squared is 4, times square root of 5 squared is 5, so 4 times 5 is 20. Plus y squared is equal to 25. So we'll subtract 20 from both sides to get that y squared is 5, which means that y is the square root of 5. And since we're in the fourth quadrant, the y is going to be negative. So this is going to be negative square root of 5. So now that we have the two triangles and we have all three sides of each triangle, we can find part A, the sine of alpha minus beta, and part B, the tangent of alpha minus beta. So the sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. And before I go ahead and plug all this in there, I'm going to write down what everything is. Then it'll be a pretty easy just to substitute everything in. So the sine of alpha, if we come back up here, sine is opposite over hypotenuse, so that's going to be 3/5. So I'm going to take out this whole thing, sine alpha, and just replace it with 3/5. I want to caution you here, don't put 3/5 in for alpha. It's not the sine of 3/5. The sine of this angle, whatever it is, the sine of the angle is the opposite over the hypotenuse, which is 3/5. And then the cosine of alpha is the adjacent over the hypotenuse, so that's 4 over 5. And then for beta, we've got the sine of beta. We're going to go over to the other triangle. Sine of beta, again, is opposite over hypotenuse, so that's negative root 5 over 5. And the cosine of beta is adjacent over hypotenuse, so it's 2√5 over 5. Now I can take these numbers. So I've got the sine of alpha. I'm going to replace it with that. I've got the cosine of alpha over here. I'm going to replace it with that. I've got the sine of beta, which I'm going to replace over there. And the last one, I have the cosine of beta, which is going to go over here. So I'm going to replace each of these highlighted trig functions here with their appropriate values. So now I've got sine alpha, which is 3/5, times cosine beta, which is 2√5 over 5, minus cosine alpha, which is 4/5, times sine beta, which is negative root 5 over 5. And then we'll do some simplifying here. We'll multiply straight across for both of these fractions. So I've got 6 root 5 over 25, and then minus a negative, so that'll be plus 4 root 5 over 25, which gives us 10 root 5 over 25, which will simplify, divide by 10 here, so that's 2 root 5, divide by 5 here, divide by 5 in the numerator and denominator, so that'll give me 2 root 5 over 5. So the 2 root 5 over 5, that's what sine of alpha minus beta is. Alright, then moving on to part B. So this is part A, and then part B over here. I've got tan alpha minus beta, so I've got tan alpha minus tan beta over 1 plus tan alpha times tan beta. So again, let's go ahead and find tan alpha, tan beta for this. So I've got that the tangent of alpha, we're going to go over to the triangle over here. Tangent is opposite over adjacent, so that's going to be 3/4. And the tangent of beta, going over to this triangle, is going to be opposite over adjacent, so that's negative root 5 over 2 root 5. And these root 5s are going to cancel, so we just end up with negative 1/2 for those two values. Alright, so now we only have two values to plug in. I've got tan alpha is 3/4, so I'm going to plug that in here and here. And I've got tan beta is negative 1/2, so I'm going to plug that in there and there. So let's go ahead and do that. So I've got tan alpha, which is 3/4, minus tan beta, which is negative 1/2, over 1 plus tan alpha, 3/4, times tan beta, negative 1/2. So in the numerator I have 3/4 plus 1/2, and then in the denominator I have 1 minus 3/8. So we can use our smiley face method down here if we want to. We don't necessarily want to because it's going to give us a denominator of 8. I guess it doesn't matter. We could try it. So we'll do 2 times 3 is 6, and 4 times 1 is 1, and then 4 times 2 is 8. And then over here, this 1 is really 8 over 8. Again, just finding a common denominator. So 8/8 minus 3/8 is 5/8. So then I end up with 10/8 divided by 5/8, which is 10/8 times 8 over 5. Those are going to cancel. I'm left with 10/5 or 2. So again, I've got tan alpha minus beta is equal to 2. Alright, if you have any questions or you're not sure where these numbers came from, make sure that you ask, and we will see you in the next video.